Today we're going to talk about special right triangles. This is going to be one of the tools in our tool belt for solving these right triangles that we're going to use all unit. This is going to be the easiest, fastest, most accurate method for us. I think in Algebra 2 you've already seen these special right triangles, I believe. So this might be a review for some of you, and for others this is going to be brand new. So, when we are solving right triangles, we're going to see a lot of methods in this unit. The easiest by far is what we are going to do today, is these special right triangles. Pythagorean theorem is a pretty close second, but it is a little bit time consuming. So we try not to use it if we have special right triangles because they're much faster. So we're going to see a couple more methods as well, but we will start ranking which ones you should always go to first and which ones are going to take a long time and you should probably save for last. So you see these two diagrams. These two diagrams are for you to memorize. This is something that just has to be memorized. It'll come quickly to you eventually. And then these will be like second nature to us, hopefully. We have two different kinds of triangles here. They are special right triangles. They have very, very creative names. The first one is called a 45, 45, 90 triangle. And hopefully you can guess why that is. It's because the angles are 45, 45, and 90 degrees. And the other kind of triangle, again, very creatively named, is called a 30, 60, 90 triangle. And within these two triangles, we have different values for their side lengths that we are going to memorize so that we can very quickly get these answers. In a 45, 45, 90 degree triangle, this is an isosceles triangle, and we know that because the two base angles are the same. In an isosceles triangle, we know that the two legs are congruent. So let's hypothesize that those legs are a value x, okay? Both of the legs should be x. The hypotenuse of my 45, 45, 90 degree triangle, which is always across from the right angle, is then whatever that value for x is, whatever the value of our leg is, times radical 2. So that's kind of like our magic number for special right triangles for specifically 45, 45, 90, is that radical 2. If I were going from a leg to the hypotenuse, I would be multiplying by radical 2. And if I was going backwards, I'm going to erase this little line. If I was going backwards here, I would be dividing by a radical 2. Okay, so if I have the leg, I multiply by radical 2. If I have the hypotenuse, I divide by radical 2 to get the leg. Does that make sense? Fantastic. Things get a little bit trickier when I talk about 30, 60, 90. There are three different angles, the 30, the 60, the 90. The most important one is across from the 30 degree angle. We call that the short leg. Everything relates back to the short leg. Okay, let's hypothesize that the value of that short leg is x. To get to the hypotenuse from that value, I'm going to multiply by 2. If I have the hypotenuse, to get back to the short leg, I would divide by 2. And then the third part is called the long leg. And that magic number is radical 3. So different from the 45, 45, 90s. Those are radical 2. In a 30, 60, 90, it's radical 3. And we kind of do the same thing here. To get from our short leg to the long leg, we are multiplying by radical 3. To get from the long leg to the short leg, we're going to divide by radical 3. Okay? So technically there's just 3 values that we need to know here. We need to know the radical 2, we need to know the radical 3, and we need to know 2. Questions on that so far? Okay. We're going to start out with 45, 45, 90 degree triangles first. So we're focusing on this first diagram here. Our magic number is radical 2. Everything comes from the legs here. So if I already have that the leg is 25, I know that the other leg is going to be congruent. So it should be also 25. And then to get to the hypotenuse, I take my magic number, which is radical 2. I'm going to multiply the leg times radical 2. We should always have exact values here. We should never get anything with crazy decimals. We should always have exact values with simplified radicals or fractions if we must. Any questions on that? Okay, then we make it a little bit difficult. We start with the hypotenuse, and I need to go backwards to get the leg. Well, if I'm going backwards, I'm dividing by that magic number, radical 2. So 17, my hypotenuse, divided by radical 2, 17 over radical 2. However, we know the rule that we cannot leave a radical in the denominator, so we need to rationalize that denominator. So I'm going to multiply by radical 2 over radical 2. We get 17 radical 2 over 2. I do not want to see any decimals or anything. 17 over 2 is perfectly fine. If you had something that could simplify, like if it was 16 over 2, you could simplify that to 8, but that's good how it is. So that's for y. X is the same because it's also a leg, 17 radical 2 over 2. Questions on that? Okay, number 3. Again, I'm starting with a leg, so I know my other leg right away is 48. To get to the hypotenuse, I take that leg, I multiply by radical 2. Hopefully, these should start coming real easy and quick for us. The faster we can get these, the better. Hopefully accurate as well. Okay, good with the 45, 45, 90s. We're going to move on to the 30, 60, 90s. Again, in the 30, 60, 90s, the most important side is that short leg. Everything has to come back to the short leg. So I already have the short leg, which makes it easy. The hypotenuse, I take that short leg, I'm going to multiply by 2 to get 22. And the long leg, I take that short leg, I multiply by radical 3. Nice and easy. Any questions on that? Well, what happens when I don't have the short leg? What happens if I start with the hypotenuse? Our process is essentially the same. We have to get the short leg first so that we can find that long leg afterwards. So if I'm starting with a hypotenuse of 8 radical 3, I know to get to the hypotenuse, I multiply by 2. So to get backwards from the hypotenuse, I need to divide by 2. So 8 radical 3 divided by 2 simplifies to 4 radical 3. And now to get from that short leg to the long leg, I'm going to multiply by radical 3. 4 radical 3 times radical 3. Radical 3 times radical 3 is 3. So that value is 12. Any questions on those? Well, let's keep going. In number 3, I start with the short leg, which is always good news for me. I'm going to take that short leg and multiply it by 2 to get the hypotenuse. That's 10 radical 3. Then I'm going to take that short leg once again, 5 radical 3, and multiply by radical 3. 5 times 3 is 15. Any questions there? Hopefully it's clicking, it's making sense. What about number 4? What do we think? I'm starting with the hypotenuse. What part do I need to get first here? Caitlin? Yeah, how are we going to get x? Perfect, 15. With that 15, now I need the y, which is the long leg. So I'm going to multiply that by radical 3. What did I just say? 15 radical 3. Number 5, I'm starting with the long leg. So the first thing I need to do is get that short leg. What's the short leg here? Casper? It is 21. We take 21 radical 3. We're going backwards, so I'm dividing by that radical 3, and they cancel out. So that's just 21. So x, double it, 42. Amazing. Last one like this. I'm starting with my hypotenuse. The short leg is what? Anybody? We're dividing by 2. 52 divided by 2 is 26 radical 3. And then long leg. We take that 26 radical 3. We're going to multiply by radical 3. 26 times 3 is, I don't even know. Oops, I'm not on the right page. 78? That sounds right. Okay. Any questions on that? We're going to do 2 word problems, which I think are good, worthy word problems, and then we will do a little whiteboard activity. Okay, a square garden has sides 100 feet long. You want to build this brick path right here. We want to know how long will that path be? What kind of triangles do we have in here? Yeah. They are isosceles. They're 45, 45, 90. We know that because these are congruent, so these must also be congruent. They are 45 degrees each. So if the leg of my 45, 45, 90 triangle is 100, the hypotenuse is... what's the hypotenuse? I take the leg, I multiply it by... did I say something wrong? Yeah, I'm going to multiply by radical 2. 100 times radical 2 is 100 radical 2. In your math labs, it's going to ask you, I think for most of the word problems, to get this into a decimal form. So you could just multiply in your calculators 100 times radical 2. I think for all the other questions, it'll look for exact answers, so with the radicals in it. But we're going to put feet next to that. That's all for that one. Any questions on that one? Okay, I love this next problem. You will definitely see a problem like this pop up in a quiz or a test, so maybe star it. Just saying. Assume the figure below is a kite. Find the values of x and y. So in a kite, we get a lot of fun properties. One of those properties is that the diagonals are perpendicular. So I do get a bunch of right triangles in this diagram. On the bottom, I have a 30, 60, 90 triangle. That's not true of every single kite, but in the kites that we're going to see for the purpose of this lesson, they are going to be 30, 60, 90s. The hypotenuse of that 30, 60, 90 is 15. So we got to find everything else. We're going to find y. To find y, which is the long leg, I need to find this piece, which is the short leg. So I'm going to take that hypotenuse, divide it by 2 to get that this is 7.5. So y must be 7.5 radical 3. Or we could just say, maybe this is nicer, 15 radical 3 over 2 might be nicer. And then another property that we get with kites is that the shorter diagonal is bisected. So if those two pieces are congruent, this is also 7.5. So then my hypotenuse, I'm going to multiply that by radical 2. This should be 7.5 radical 2, or if you want to get fancy with your fractions, 15 radical 2 over 2. Okay. Any questions on that?